I'm Ranjith Reddy from the Department of ECE in St. Peter's Engineering College. Now I'm going to discuss about satellite orbits from satellite communications. So the first one is satellite orbits. So what is meant by orbit? Orbit is nothing but the path which is used to rotate the satellites around the earth, or a smaller body which is used to rotate around the bigger body. So let us consider this is the earth. Okay, so let us consider this is the satellite. So the satellite which is used to rotate the path which is used to rotate around the earth is simply considered as orbit, right? So there are different satellite orbits are classified. So based on the inclination, the first one is based on inclination, and second one based on shape, and third one based on altitude or height. Okay, so the satellites orbits are classified into different types based on the inclination, based on the shape, and based on the altitude. So based on the inclination, it's again classified into three types. The first one is equatorial orbit, and second one is inclined orbit, and third one is polar orbit, right? So based on the shape, it is again classified into two types: circular orbit and elliptical orbit. And based on the altitude, it is again classified into three types. The first one is LEO, low Earth orbit. Second one is MEO, medium Earth orbit, and third one is GEO, geostationary Earth orbit. So the first one is the first classification based on the inclination. The first one is the equatorial orbit. So what is meant by equatorial orbit? Okay, so the equatorial orbit is nothing but the satellite is revolving just above the equator of the earth is simply considered as equatorial orbit. So this is simply considered as the equatorial orbit. Okay, so let us consider this is the satellite. The satellite is rotate or revolving just above the equator of the earth is simply considered as the equatorial orbit, and the inclination angle of equatorial orbit is 0 degrees. And the second classification is polar orbit. So the polar orbit is nothing but the satellite is rotate in between North Pole to South Pole, or it is perpendicular to the equator. Let us consider this is the earth. Okay, it is the orbit which is rotate, or the satellite which is rotate, okay, North Pole to South Pole, or it is directly perpendicular to the equator of the earth. It is simply considered as the polar orbit. And the inclination angle of polar orbit is 90 degrees because it is perpendicular to the equator, that is nothing but 90 degrees. And the third one is inclined orbit. So inclined orbit is nothing but other than equatorial and polar, remaining all orbits is simply considered as the inclined orbit. So in inclined orbit, the inclination as angle is varies between 0 degrees to 180 degrees. So let us consider So let us consider this the Earth. The satellite is rotated just above the equator is simply considered as the equatorial orbit. The inclination angle is 0 degrees. Next, the satellite is rotated north pole to south pole or perpendicular to the equator of the Earth is simply considered as the polar orbit, and the inclination angle is 90 degrees, right? So other than equatorial orbit and other than the polar orbit, remaining all orbits simply considered as the inclined orbits. So these two are simply considered as inclined orbit, and the inclination angle is varies between 0 to 180 degrees. So this is the classification about or based on the inclination. So second one is based on shape. So it is classified based on the shape. The satellite orbits are classified into two types. The first one is the circular orbit. So the based on the shape, so the satellite orbits are classified into two types. The first one is the circular orbit, second one is the elliptical orbit, and these two orbits are defined based on the value of eccentricity. So eccentricity is denoted with E. So the value of eccentricity is defines the which type of orbit is used, that is circular orbit or elliptical orbit. So the formula for eccentricity, the eccentricity is used to define the shape of the orbit, that is nothing but square root of a square minus b square by a. So here a is nothing but semi-major axis and b is nothing but semi-minor axis. So let us consider this is the elliptical orbit. This is considered as semi-minor axis. This is considered as semi-major axis. So right, by observing this, A is greater than B. Right. So if A is greater than B, what happens? The eccentricity of the value is in between 0 and 1. That means A is always greater than B is nothing but, so therefore the shape of the orbit is elliptical. So if A is equal to B, that means if the semi-major axis and semi-minor axis both are equal, what happens? The shape is like circular. That means if A is equal to B, what is E? E is equal to 0. So that means in circular orbit, if eccentricity is equal to 0, therefore the shape of the orbit is simply considered as the circular orbit. And second one is elliptical orbit. In elliptical orbit, the semi-major axis is always greater than B. That means E is in between 0 and 1. Such type of orbit is simply considered as the elliptical orbit. That means the shape of the orbit is defined majorly based on the value of eccentricity. That is E is equal to square root of a square minus b square by a, where a is the semi-major axis, that means here to here, and b is the semi-minor axis. If both a and b are equal, then eccentricity is 0. If E is equal to 0, such that for example, this is A, B, B. If both A and B are equal, therefore the orbit is simply considered as the circular orbit, right? If A is greater than B, such type of orbit is simply considered as the elliptical orbit. Next one, based on altitude. So based on altitude, the satellite orbits are classified into three types, that is first one is LEO, second one is MEO, third one is GEO. Here LEO is nothing but low Earth orbit. So low Earth orbit. Here LEO is nothing but low Earth orbit. This is the Earth. Okay. So the satellite is rotating at a distance from the center of the Earth is about 500 to 2000 kilometers. Such type of orbit is called as low Earth orbit. That means the low Earth orbit is present at a distance of 500 to 2000 kilometers from the Earth's surface. Such type of orbit is simply considered as the low Earth orbit, right? So in the low Earth orbit, if the satellite is present in the low Earth orbit, in this orbit, this is Leo, the satellite is present in the low Earth orbit, okay, for one complete rotation it will take approximately 90 minutes to 120 minutes. So for one complete rotation, if the satellite is present in the Leo, that means low Earth orbit, it will take approximately 90 to 120 minutes. So next one, MEO. MEO is nothing but medium Earth orbit. Okay, so the orbit is present at a distance from the Earth's surface is approximately 2000 to 35,786 kilometers. So such type of orbit is called as medium Earth orbit. Okay, so the orbit is present at a distance from the Earth's surface to approximately 2000 to 35,786 kilometers. Such type of orbit is simply considered as the MEO, medium Earth orbit. Okay, if the satellite is present in the medium Earth orbit, okay, for one complete rotation around the Earth, it will take approximately 6 hours. It will take approximately 6 hours time. So, and the third one is GEO. Third one is GEO. So GEO is nothing but geostationary Earth orbit. Okay, so GEO is nothing but, there are three types of satellite orbits based on the altitude or based on the height. The first one is LEO, MEO, and third one is the GEO. And the GEO is nothing but geostationary orbit. Okay, so the orbit which is present at a distance of greater than 35,786 kilometers. So greater than 35,786 kilometers from the Earth's surface. So such type of orbit is simply considered as geostationary Earth orbit. Okay, so if the satellite is present in the geostationary Earth orbit, okay, for one complete rotation around the Earth, so it will take approximately 24 hours time. Okay, so for LEO, it is at a distance of 500 to 2000 kilometers from the Earth's surface. So such type of orbit is simply considered as the low Earth orbit. So for one complete rotation, if the satellite is present in the low Earth orbit, for one complete rotation, it will take approximately 90 to 120 minutes, right? In the second one, if the satellite orbit is present at a distance 2000 to 35,786 kilometers from the Earth's surface, such type of orbit is simply considered as the medium Earth orbit. If the satellite is present in the MEO, it will take, for one complete rotation around the Earth, is approximately 6 hours. So, and the last one is the, if the satellite orbit is present at a distance of greater than 35,786 kilometers from the Earth's surface, such type of orbit is considered as the geostationary Earth orbit. If the satellite is present in the GEO, so for one complete rotation around the Earth, so it will take approximately 24 hours. So let us consider the coverage area of the LEO is very, very less, and the coverage area of the MEO is moderate compared to LEO and MEO, and the coverage area of the GEO is very, very high. The propagation delay of the GEO is very high, and the propagation delay of the MEO is moderate, and the propagation delay of the LEO is very, very less. Right? Next, approximately 30 to 60 satellites are required in order to communicate globally with the help of LEO. That means if the satellites are present in the LEO, so approximately 30 to 60 satellites are required for complete global communication. Okay, if the satellites are present in the MEO, approximately 10 to 15 satellites are required for entire global communication. So coming to GEO, only 3 satellites are required for entire global communication, and those 3 satellites are placed 120 degrees with each other. Right? And the major applications of the LEO is The low Earth orbit, the major applications are weather forecasting and mobile communication. So whereas the MEO for GPS applications and for navigation purpose, and the major applications of GEO, all TV and radio broadcasting. Thank you.